Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing the concept on composition of coplanar non-concurrent force system. So the word composition means it is the procedure of determination of resultant of system of forces. And coplanar non-concurrent force system, it is a type of force system wherein coplane, same plane, non-concurrent, the forces which are not originating from the same origin or same point is called as non-concurrent. So here basically we are supposed to determine the resultant of the force system which are lying in the same plane but not having the same origin. So here we have a numerical for better understanding of the concept over here. So here we are supposed to determine the resultant of a given figure with respect to the point A. And here we have a grid system wherein A, B, C, D are the total grid and the individual grid is of 200 by 200 mm. On all the dimensions are represented in mm here, and we have a series of forces here, and also we have an external moment which is a clockwise moment having the magnitude of 200 Newton mm. So step 1 of this numerical is that we need to determine the angle of inclination. So here the first force I have taken as 200 kilonewton, and for that the angle of inclination is theta with reference to horizontal I have mentioned, and the vertical distance which is represented by the red arrow mark here. So the vertical distance is equal to y and the horizontal distance is equal to x. So both are equal to three small grids. So therefore it is equal to 600 mm and 600 mm. So tan theta is equal to y by x. So theta will be equal to 45 degree. Similarly, for 500 kilonewton we have two grids in the vertical direction which is equal to 400 mm and one grid in the horizontal direction which is equal to 200 mm. So theta 1 is the angle of inclination with reference to horizontal. So tan theta 1 will be equal to y1 by x1. So theta 1 is equal to, after simplification I am getting as 63.43 degrees. So this is the resolved forces for the inclined force with reference to theta and theta 1 which I have got in the previous slide. So this is the step which is included for the calculation of the resultant. So the resultant we are supposed to calculate with reference to the summation of all the horizontal and vertical forces. So here this horizontal forces is calculated as sigma h. So before calculating sigma h, the summation of all the horizontal forces, so I am going to consider the sign convention as right side going forces as positive and left side going forces as negative. So this is the sign convention which is followed for calculation of the horizontal equilibrium. So that is sigma h equal to 200 cos 45. We have three forces in the horizontal direction. So 200 cos 45 and then 500 cos 63.43 and 150 all are going in the right side direction. Hence it is equal to the positive value itself. So that is 644.97 after simplification. So we are getting in terms of kilonewton. So next is sigma v equal to 200 kilo. We are going to take sigma v. Before the sign convention of that is downward negative and upward positive. So with that we have we have the system of forces as 200 and 200 sine 45 in the upward direction and 500 sine 63.43 in the downward direction. So after all simplification we are getting it as 505.77 kilonewton which is acting in the downward direction. Hence it is represented by downward arrow mark here. So next is calculation of the resultant, it is nothing but the under the square root of sigma h square plus sigma v square, and therefore R is equal to 819.62 kilonewton. Now coming on to the important step is determination of moment about point A. So before going to calculation of moment about point A, we need to understand the concept of moment. So moment is basically equal to product of force and its perpendicular distance with reference to the reference point. So here the point of reference is equal to A. So as we know that we have the force system, so all the force system cannot be considered for calculation of the moment, because some of the forces which are passing through the line of action of the reference point, their moment should not be considered. Why? Because see, if I just draw the line here and the line of action which is passing through point A. So if I just draw it like this, the line of action which is passing through point A. So this is with reference to y axis, and this is with reference to x axis. This is with reference just passing through line of action which is passing through point A. So which all the forces which are lying on the same line of action, that force should not be considered. For example, it is 150, 200 and 200 sine 45. Why? Because the force will be existing, but its perpendicular distance with reference to that point will be equal to 0. So 0 into something will be 0. So therefore we cannot consider that force action as the moment action on the reference point. This is the point which is very important for the calculation of moment with reference to some individual point. So here moment is calculated as, so 200 cos 45 we have. Apart from that, we have these forces. So 200 cos 45 we have. So based on that, the vertical distance is 600. So 200 cos 45 into 600, go along the force through the line of action and touch the point A. So it is the anti-clockwise moment, hence it is negative. Next, 500 sine component here, it should not be considered. Next, 500 sine 63.43. So for that, the vertical distance, the horizontal distance is equal to 800. So it is the clockwise moment like this. So which is passing through point A. It is a clockwise moment. And then apart from that, cos component of 500, which is having the vertical distance of 600 again, and go along this force, touch the point A, it is the anti-clockwise moment. So with reference to this, we have solved and got the moment as equal to 140.715 into 10 power 3 Newton mm. So before that, even we have also taken this 2000 into consideration. So since this is the moment calculation, so whenever the external moment has been given, so based on its direction, if it is clockwise, then positive, anti-clockwise, then it is negative. So based on its direction, we are supposed to take that into consideration for the calculation of the moment, but not for the calculation of the resultant. Why? Because resultant is the equilibrium of force, but moment for it cannot be considered for the moment system. So here next thing is determination of perpendicular distance from perpendicular distance of resultant from the reference point. So as a whole, the resultant which I have got is from sigma h and sigma v. So with reference to that, I have just drawn x and y axis. On sigma h and sigma v, I have got and the resultant is over here. And if at all, if it is represented, so d is the perpendicular distance with reference to the resultant, and that d can be calculated as moment is equal to summation of the resultant and its perpendicular distance. So therefore, so d is calculated as 171.68 mm. So with reference to the reference point of A, so resultant is in 171.68 mm distance with respect to point A. So that is what the inference with reference to this sketch. Thank you for watching. Please like, share and subscribe the video. Thank you.